Hey everyone, this is our last topic in Unit 7b, and it is on linear versus exponential comparison. So in a previous unit, we learned about linear functions. In this unit, we learned about exponential. Now we're going to compare them and just put them together side by side. So to start, we have a graph of both a linear and an exponential function, and the graphs look very different. A linear, just like the stem of the word line, makes a straight line. A linear graph makes a straight line. And if a linear graph makes a straight line, it means, if I zoom in on this a little bit, it means that the slope is the rise over the run. So if I actually count this slope from this point to this point, I get 1, 2, up 3, right 1. I get up 3, right 1, which is just 3. I'm going to write one more word here. The slope is constant. All right, let's look over here at our exponential graph. Now, an exponential graph is very different because if I pick 2 points, say this one, and then if I pick another 2 points and another 2 points, the slope is different every time. Look at this one. It's up, it looks like a half and over 1. This one looks like up a 1.5 and over 1. This one is up 4 and over 1. The slope is not constant, which means that we can't find a slope for this problem because it's multiple different numbers. Okay? So let's look at the next one. This is if we just have a sequence of numbers. So we can also see sequences of numbers. It just means a series of numbers. So if we look at the sequence of numbers, and I went from 1 to 4, and then from 4 to 7, and the 7 to 10, the pattern is up 3 plus 3. So the pattern is positive 3, and that is addition. And if you look at this sequence of numbers, from 2/3 to 2, from 2 to 6, from 6 to 18, this pattern is very different. It's still getting bigger, but this pattern is times 3, right? So we have a pattern of multiplication when we have a exponential equation. Okay, so now we took our graphs, our original graphs, we put those graphs in a table. It's also just this list of numbers, 1, 4, 7, 10, 13. Here, 1, 4, 7, 10, 13. We put them in order. And now when we're trying to find a pattern in a table, we just look at the outputs. And our outputs, same as we already found above, are going up by 3. And they do that every time, right? You can check over here if you want, +1, +1, but it's all the same, right? That means the common difference, or the pattern, is 3. And the pattern in this case is +3. All right, and this one, common ratio. That word ratio means that we're not adding anymore. We're multiplying. Times 3, times 3, times 3. So the pattern is times 3, and the common ratio is just 3. So in this case, we actually wrote this the same, right? But a common difference is 3. A common ratio is 3. So this means addition. This means multiplication. All right, lastly, we have our explicit and our recursive rules. So we'll do explicit first. Now we've covered explicit in a different unit for linear functions. The key is I'm going to look at my table, and I know that something important that you need for all of these rules is, and I'm going to highlight it, is this point 0, 4. So I'm going to write up here that the y-intercept is 0, 4. And remember, our common difference is 3. So to write an explicit rule in a linear function, it looks like this. y equals, and first we write our slope, which is 3, then the letter x, and then we add our y-intercept. And underneath it, I'm just going to write the format. The format looks like this. f of x equals mx plus b. That should look very familiar. All right, I'm going to go over here and do the explicit rule for my exponential. In the table, here's my point again. This is very important. This is my y-intercept. So I'm going to write y-intercept is 0, 2. The other thing that's important is that my common ratio is 3. So my explicit rule for an exponential, this should be very familiar because it's recent. Looks like this: y-intercept first, in parentheses, the number 3, exponent of x. So I'll put underneath here a parentheses b to the x power. All right, so now we're going to write a recursive rule for both. I'm going to do the recursive rule for my linear first. So for my linear, it always starts like this: f of 0, and I go to my table and put the point that goes with 0, which is 0, 4. All right, f of 0 equals 4, and then I write f of x equals f of x minus 1, and what comes next is the pattern. So I'm going to write my pattern, which is add 3 plus 3. And these together are my recursive rule. Recursive for exponential looks very similar. We write g of 0 equals, and I find that point, equals 2. And then I write g of x equals g of x minus 1, and here is my pattern, which in this case is times, what's my common ratio? 3. So there is really explicit recursive. It's a summary of all of this stuff that we've done all year. I'm going to put a box around these two as well. It's really a summary of a lot that we have done this year. All right, you're going to practice one of the last homeworks in your packet. I think it's number 5 for homework. All right, good luck.